My name is Dana Hernandez, and I am a PhD candidate in Professor Ashok Gadgil's research group in the Department of Civil and Environmental Engineering at UC Berkeley. Coal-fired power plants in the U.S. produce about 105 million tons of coal ash every year. Disposal of coal ash waste is a major problem. Historically, the coal ash was stored in large wet ash ponds, which keep on accumulating near the power plants. According to a 2019 report by the Environmental Integrity Project, groundwater at 91% of U.S. coal plants is contaminated from this coal ash waste, which has built up over decades, leaching arsenic and other toxic substances into the groundwater. At 2 of the 10 worst contaminated sites, arsenic concentrations exceed 350 times the drinking water standards. This problem is widespread. Unsafe concentrations of contaminants from ash ponds in groundwater were reported at sites in 39 states and Puerto Rico. The CERC-WET program from the Department of Energy has supported work to address this problem. In the Gadgil Research Lab, we have been developing a novel electrochemical treatment technology for arsenic removal called air cathode assisted iron electrocoagulation, or ASAI. By applying a current, we are able to electrolytically dissolve a sacrificial iron anode. A carbon-based air diffusion cathode exposed to the atmosphere induces the oxygen reduction reaction to generate hydrogen peroxide. In the bulk solution, dissolved iron in the 2+ oxidation state reacts with hydrogen peroxide to generate reactive intermediates, either the ferryl ion or hydroxyl radical, to oxidize arsenic 3 to arsenic 5, which readily adsorbs to the iron 3 oxyhydroxides that are generated in the system. The aggregated precipitates can be filtered out, leaving arsenic-safe effluent. We have scaled up ASAI from a 0.5-liter batch system to a continuous flow reactor operating at 60 liters per hour. We have designed and built upflow ASAI reactors, and we are currently building and testing a system for treating 600 liters per hour. Our team is also developing a system to remotely monitor the operating parameters such as voltage, current, dissolved oxygen, pH, and conductivity. Keeping our environment clean and our groundwater safe for communities is a national priority. Many coal power plant operators are already moving to clean up their ash pond water. Inexpensively removing arsenic from the ash pond water reduces the cost to the electricity consumers, who ultimately will have to pay for the treatment. It also protects the groundwater and the environment. This work is supported by the CERC-WET program under the U.S. Department of Energy.